All right, let's do some more examples of atomic size using more than just two elements to compare so that you get some experience with those types. Those are the type that we're mainly going to be using. So somewhere on your paper, maybe another sheet of paper. Actually, yeah, if you haven't taken out another sheet of paper yet, go ahead and get one out because these problems will take up a little bit of space. So the one we're going to do first will be comparing bromine, chlorine, phosphorus, and sulfide ion. And I'm going to ask you to put them in order from smallest to largest. And of course, again, we're not talking mass, we're talking atomic radius. So we're going to always start by writing down underneath each one of them what their valence energy level is. So for bromine, if you take a look, bromine is in the fourth period, so it's fourth energy level. Chlorine is in the third. You find phosphorus, follow it over, it is in the third. And then sulfur with a -2 is actually acting like argon in terms of its electrons. Whenever I say acting like, it means in terms of its electrons. So argon is also third energy level. So this will tell us which one's the biggest out of all of them. Okay, so if we're going to list these from largest to smallest, let's see, I'm just going to put them over here maybe in a box listed from largest to smallest. So this one right here will be the smallest one, this one will be the largest one. I know right away that bromine goes last. Okay, that bromine's going to be the biggest because it's fourth energy level. So now I just kind of mark that one off for myself so that I know I'm done with that one. Now I can decide chlorine, phosphorus, and sulfide based on not valence energy level, but we'll look at protons. So for chlorine, chlorine has 17 protons, phosphorus has 15 protons, and sulfur has 16 protons. So since they're all different, this is going to tell us what our answer is. We're not going to have to, go on and use anything else. Number of protons in the nucleus. Remember, the more you have, the smaller the atom is. The more you have, the smaller the atom is. So this one is the one that has the most, chlorine. So he's going to be the smallest. So we'll list him first. The next smallest will be the one with the next most amount of protons. So that'll be a -2, S -2. And then the biggest one out of these ones that are third energy level is the one with the least number of protons. So that will be phosphorus. Now, you have to explain your reasoning still. Okay, so it's kind of hard to do this when you're doing a group of 4 of them. But you still need to incorporate the same ideas. So what you can do is you can start by saying bromine was the largest based on its higher valence energy level. Okay, so that takes care of bromine. Then you say chlorine, phosphorus, and sulfide had the same valence energy level, but were placed in, let's see, I need some more space, order of, let's see, we put them in order of decreasing protons as less protons pull in the electrons less, making the atom bigger. Give you a second to get that down. So you can see what I'm doing there. My description is I don't have to go through each one individually. You can if it's easier for you, but in order to condense it a little bit, I talked more in general terms. We talked about how I got chlorine, sulfur, and phosphorus in their order. It was based on protons after looking at valence energy level. I stated valence energy level, and I also explained what a decrease in the number of protons means. So all of those components ended up being the full explanation. Okay. So that's one example. Now, we're going to do one more so that we can use those electrons. Let's do chlorine. We have chlorine with a -1. We'll do compared to calcium, and calcium with a +2. And again, let's go from over here, we'll put them in this box, we'll go from smallest to largest again. Sometimes it'll say decreasing order of size, which will be decreasing size, which will mean going from the biggest to the smallest. So just pay attention to the terminology. So valence energy level. Now chlorine is, just regular chlorine is going to be third energy level. Chlorine with a -1 is acting like argon, which is also third energy level. Calcium is on fourth energy level. And calcium with a +2 is actually acting like argon, right? Because it lost 2 electrons. So that would be third energy level. So once again, one of them stands out right away. We can see that calcium is going to be the biggest of all of them. So we can put calcium in right away, and then I'm not going to worry about calcium for the rest of it. So we go to number of protons. Chlorine has 17, both of those, and then calcium has 20. So looking at those ones, I can tell something else right away. I'm not going to be able to tell anything about these guys yet, but I can tell that calcium with a +2 charge, having 20 protons compared to the 17s that are in chlorine, that calcium is going to be smaller. It's on the same energy level, but it has more protons. So calcium +2 is going to be my smaller of those ones. So now it's just a matter of placing chlorine and chlorine with a -1. So the last thing we look at is number of electrons. So regular chlorine has 17. Chlorine with a -1 has 18. The one with 18 has more electron-electron repulsion, therefore making it larger. So we're going to put chlorine with a -1 and then chlorine. So the biggest one was calcium because it was fourth energy level. The next biggest one was chlorine -1 because it had the fewest protons, which made it bigger than calcium with a +2, and the most electrons. So you're going to get the most electron-electron repulsion without as much pulling in from the nucleus. Then we have chlorine with 17, and then we have 17 protons, and then calcium with 20 protons. Now for your explanation of this, I'm not going to write mine as we say it, but you can go ahead and write this down. I would start with this part. We start by saying calcium was the largest because its valence electrons were on the highest energy level. Okay, do that part first. Calcium was the largest because its valence electrons were on the highest energy level. Then you need to explain the other ones. So I would then go to calcium with the +2 was the smallest because although it shares the same valence energy level as chlorine and chlorine -1, so make sure you have a notation that it's sharing the same valence energy level as chlorine and chlorine with a -1. It had more protons, therefore making it smaller because more protons pulls the electrons in closer to the nucleus. So again, calcium with a +2 is smaller than the chlorine atoms and ions because it's got more protons in its nucleus, pulling those electrons in more tightly. And then between chlorine and chlorine -1, you've already stated that both of them were third energy level, so make sure you state that they both have the same number of protons. But chlorine with a -1 has more electrons, causing more electron-electron repulsion, which then causes the atom to be bigger because those electrons are pushing themselves out. Okay, so there's a lot going on, but all the thoughts are the same. So once you get comfortable with the thoughts and the descriptions, it's just a matter of figuring out which one goes with which.